Hello, everyone. Welcome to our webinar. During today's webinar, we are going to discuss looking at statistical assumptions. So things like normality, homogeneity of variance, homoscedasticity. We'll look at some examples in SPSS in terms of how to check for these assumptions. My name is Justin D'Souza, by the way. I'm a quantitative specialist here at the company. If you have any questions, you can type them into the chat box or the Q&A box. At the end of the webinar, we will be doing a Q&A session. My colleague Sierra has put some hyperlinks in the chat box for checking out our free dissertation resources on our website or scheduling a free consultation. So yeah, let's go ahead and dive in. First, I'll give a brief overview of the services that we provide at our company. Then we'll look at various statistical assumptions to verify and how to check for those in SPSS. And then we'll conclude with a summary and a question and answer session. All right, so on this slide, you can see all the parts of the dissertation that we assist with. We also help with master's thesis documents. So no matter where you are, if you're at the beginning of the process, somewhere in the middle, or if you're just wrapping up your dissertation, we can provide assistance, starting with topic development and framing your research questions and hypotheses, identifying a gap in the literature and finding a theoretical framework to support your study. Then going into the prospectus and concept papers, that will depend on what school you go to. Some colleges will do a prospectus, others have concept papers. Then going into the proposal chapters, so we have quantitative specialists, we have qualitative specialists, and we have literature review specialists. So depending on where you need help, we will assign one or multiple specialists to you. We can help with IRB forms. If you're not sure how your data needs to be organized, ideally for analysis, we can send you data entry templates. We can host a survey for you on our own SurveyMonkey account. We have an account at our company. And then with wrapping up the dissertation, if you just send us your data and your proposal, your methodology, we can write up an APA document for you of the findings. And then we also assist with the discussion, PowerPoints for both proposal and final defenses, and journal publications. So if you need any assistance, if you've hit a roadblock, please give us a call at 727-442-4290, or you can use the link that Sierra put into the chat box. All right, so first we will look at what is probably the most common and prevalent assumption, which is normality. So normality is the assumption that your data is following a bell-shaped curve or a bell-shaped distribution. There are many ways to check for normality. So this is one of those things where you'll have to speak with your committee. They probably have a preference. Your methodologist or your chair may have a preference for what method you use to check for normality. There are objective tests, like a Shapiro-Wilk test or a Kolmogorov-Smirnov test, that will give you a p-value that tells you definitively, do we meet the normality assumption or do we not? I tend to use those approaches more often a Shapiro-Wilk test. But there are also more visual interpretations. Instead of doing a Shapiro-Wilk or Kolmogorov-Smirnov, you can look at histograms instead. So histograms or normal QQ or PP plots, that's a visual interpretation, which is valid, but it's more subjective because everyone will interpret a scatter plot or a histogram slightly differently. So I tend to go with the objective tests. Now, if the assumption of normality is not supported, you can consider shifting to a different statistical approach. For instance, if you're planning to run Pearson correlations, which is a parametric test, and the assumption of normality is not supported, you could shift to a Spearman correlation instead. A lot of analyses will have a non-parametric backup that you can use. You could also look at removing outliers. There could be certain cases that are skewing your data set, extremely high values or extremely low values. So taking those outliers out could fix the normality issue. All right, so let's look at an example here. If you've joined us before, you've probably seen this data set. So we have 32 rows of data. Each row represents a different car model. We have Mazda cars, we have AMC, Dodge, and so forth. So for each car, we identify if it uses a manual or an automatic transmission type. We have the horsepower of the car, we have the weight of the car in metric tons, and we have the quarter mile time. So right away, I see that we have three numeric variables: horsepower, weight, quarter mile time. These are all considered continuous or interval because they fall on a range. They're numeric. We also see decimals as possibilities for a lot of these. So that is usually an indication that we have a continuous variable. And if horsepower, weight, and quarter mile time are part of your research questions, then you'll want to check for normality on these factors. So I'll show you a few different ways to do that. First, we'll look at the Shapiro-Wilk Kolmogorov-Smirnov test findings. To do that, we'll go to Analyze, Descriptive Statistics, and Explore. Then we will move horsepower, weight, and quarter mile time to this right box. And then you can click on Plots right here. And then this is the important box to checkmark: Normality Plots with Tests. You can also checkmark histogram here if you want to see a visual representation of the data. Click Continue and OK. This takes a few seconds to run, quite a big output. All right, so the first thing it's going to present are the descriptives. So you can see the mean, you can see the median, you can see the min and max values for the variables, and skewness and kurtosis. So normality is right here. Test of normality. We have both the Shapiro-Wilk in the right column here, and we have the Kolmogorov-Smirnov in the left column. You typically will not report both. So early on in your methodology chapter, you need to pinpoint one method, one specific method to check for normality, and then just be consistent throughout the chapter. You don't want to report it multiple ways because sometimes the findings can contradict one another. In this case, they don't. So the takeaway here is significance. The p-values will tell you, do we have data that follows a normal distribution or not? This is a rare time in statistics where significance is actually not an ideal finding. We want to see non-significance on these tests. So for horsepower, the p-value or the significance is below 0.05, and it's below 0.05 here for the Shapiro-Wilk as well, meaning that horsepower does not resemble a bell-shaped curve. What this is saying is that horsepower, the distribution for horsepower is significantly different than a perfect bell-shaped curve. So horsepower violates normality. Weight of the car and quarter mile time, the p-values for these are greater than 0.05. So we do meet the normality assumption for weight and quarter mile time. So for horsepower, a couple things you can do are look for outliers, which is the next thing we're going to check. And you can also consider using non-parametrics instead. I'll show some examples for that as we proceed. We also have the histograms in here. So if you were going for a more visual interpretation for normality, this is what you can use. As a histogram, we can clearly see that it's skewed to the right. So this does not visually show anything like a bell-shaped curve, which justifies what we saw up here. And then the histogram here for weight, this more resembles a kind of a bell-shaped curve. Still doesn't look great. The sample size is a little small for this as well, something to keep in mind. And then quarter mile time. This really does resemble a bell shape. Okay, so that is the assumption of normality. Next, we can look at outliers. Okay, so how do you check for outliers? You can use box plots. That's one method. I tend to use z-scores. I follow this citation here to Bachnik and Fidel. They say to standardize your scores, meaning convert them to z-scores, and any values exceeding 3.29 or lower than negative 3.29 are considered outliers. So really easy to do this in SPSS. All you need to do is go to Analyze, Descriptive Statistics, and Descriptives. Then put in horsepower, weight, and quarter mile time into this right box, and then check mark this option right here. Save standardized values as variables. Once I click OK, you will see a copy as variables. So we have horsepower right here, and we have the z-score for horsepower. So this is a standardized version of horsepower in relation to the mean. All right, so following the citation here, they say any z-scores larger than 3.29 are outliers. So all we need to do is sort these z-score columns in ascending and descending order. So if I do descending, that is going to bring the high values up to the top. And we have this case here. The Maserati Bora had a horsepower of 460, and the z-score for this was 3.53. A 3.53 is larger than 3.29. So technically, we do have a high outlier for this. So you could consider removing that case altogether. You could consider replacing it with the average. There are many ways to handle outliers. So that will be another question for your committee is, should I just remove it altogether? Should I replace it with something? But then you do the same thing, okay? So we looked at weight. We look at weight, sort it in descending. 2.25 is lower than 3.29. So no outliers for weight in the high direction. And then quarter mile time. The highest z-score is 2.83. That is not larger than 3.29. So no high outliers for weight or quarter mile time. Then we need to see in the low direction. Do we have any very low values? So negative 3.29. We sort in ascending order now. So that will bring the low values to the top. Negative 1.16 is not lower than negative 3.29. So no low outliers for horsepower. Negative 1.74, no low outliers for weight. And then negative 1.87, no low outliers for quarter mile time. So that's a way you can check for outliers. Then we go into homogeneity of variance. So this is a common assumption you'll see if you're running independent t-tests or perhaps ANOVAs. And the common way to check for this is with Levene's test. Okay, so to do this, homogeneity of variance is actually built into t-tests and ANOVAs, so you don't have to go through a separate menu to do this. You just run a t-test. Okay, so first we'll go to Analyze. We'll go to Compare Means and Proportions, and then we'll just run a hypothetical t-test here. All right, and to do this, we'll put horsepower, weight, and quarter mile time over here. And we'll put transmission type down here, just as a hypothetical. I need to assign the groups here. Automatic and manual. All right, the research question for this would essentially be, is there a significant difference in horsepower, weight, or quarter mile time based on transmission type? Before I do this, I need to convert transmission to a number. So automatic will be a 1, manual will be a 2. This is a good thing to come up during this webinar. Sometimes you have to convert words to numbers like this. This is transmission type. And here I can assign the values for it. So 1 is automatic, 2 is manual. Automatic, 2 is manual. That, and then let's rerun that t-test. Okay. And this is what a t-test output looks like. The first thing it gives you are the descriptives at the top. So what is the horsepower for an automatic car? What is the horsepower for a manual car? And likewise for weight and quarter mile time. Then you have the findings of your t-test in this big table. And within this table, we have the homogeneity of variance assumption findings. It's right here, Levine's test for equality of variance. So we are checking for this. Homogeneity of variance and equality of variance are synonymous. It's the same thing. The interpretation for this is very much like the Shapiro-Wilk and Kolmogorov-Smirnov test we looked at for normality. Significance is not an ideal finding for this. So we want p-values greater than 0.05 for Levine's test, and we do meet that assumption. 0.059 is greater than 0.05, and then 0.841 and 0.591 are both larger than 0.05. Therefore, homogeneity or equality of variance is supported. And when you interpret your t-test, you will then use the corresponding row. So because equality of variance was supported, we will use this row here. Equal variance is assumed. You would report this t-value, this degree of freedom value, and these p-values. Likewise for weight and quarter mile time. Hypothetically, say that we had a significant result on Levine's test here, the p-value was 0.042, then that would mean equality of variance was not supported. And we need to use the second row here for the t-test. So we would report this t-value, this degrees of freedom value, and these p-values. Okay, that is homogeneity of variance. Next assumption is linearity. This is more run if you're doing correlations, like Pearson correlations or linear regressions potentially. And all this is doing is running a scatter plot so you can visually see the relationship between your independent and your dependent variable. To do this, you will go to graphs and then chart builder right here. And then we need to select a scatter plot template, which is at the bottom here, scatter plot, and then click and drag the template up here. And we need a hypothetical research question for this. So let's say, what is the relationship between the weight of a car and the horsepower of the car? We can put weight down here on the x-axis, and we can put horsepower on the y-axis, and then click OK. And this is going to generate a scatter plot. So we can clearly see that there does appear to be a slight trend here. As weight increases, the horsepower also does appear to increase slightly. We can add a summary regression line to this. If you double click the plot, it's going to bring up the chart editor like this. Then go to elements and fit line at total. This will draw a summary regression line that depicts the directionality of your relationship. So we can clearly see that there is a positive association between weight and horsepower. All right. And then the final common assumption is absence of multicollinearity. This is done when you're running multiple regressions. If you're doing a multiple linear regression or maybe a multiple logistic regression, absence of multicollinearity is making sure that your independent variables are not strongly associated with one another. You want them to be fairly independent when you're running a regression. So the common way to check for this is with variance inflation factors. And if your VIFs for short are below 10, then the assumption is supported. So to run this, we need to build a hypothetical regression model. So we'll go to Analyze, Regression, Linear, and let's put in quarter mile time as the dependent variable, put horsepower and weight as the independents. And within a regression model, there are a lot of assumptions you can check within the regression module itself. So the first one, we'll go to statistics here. That opens up this box. And for multicollinearity, we're going to check mark this option right here, collinearity diagnostics. Then there are other assumptions you can check. If you go to plots, we can check for normality of the residuals by checking this option here. And then we can check for another assumption called homoscedasticity by putting Z predictor here and Z residual here. Click OK, and that's it. Okay, so this is going to generate the entire regression output, and the assumptions will be scattered throughout here. So the first one we'll look at is absence of multicollinearity. So ideally, we need the VIFs to be below 10 to meet this assumption. And if you look in this coefficients box, the final column has the VIFs. We can see 1.4 is the value, which is below a 10, meaning that there's a low association between horsepower and weight, which is a good thing for a regression model. So absence of multicollinearity is supported. Then as we scroll down, you can see the normality check. So this is normality of the residuals. And you'll almost always run this if you do a linear regression. Ideally, you want your little, the blue circles here, which are your data, you want it to follow this diagonal trend line, which it does quite closely. So I would say normality is supported. And then this is a residual scatter plot used to test for homoscedasticity. And all you want to see in this plot is random scatter, random spread, showing independence of the observations, which we do have here. So homoscedasticity is also supported. All right, and that is the final assumption. Okay, so those are the most common ones: normality, outlier checks, homogeneity of variance, linearity, and absence of multicollinearity. You can check out Statistics Layered, which is a great resource for knowing what assumptions should you check. So for instance, if you're running a linear regression, just put linear regression into Google and then type Statistics Layered. That. And then you can open the first hyperlink here, and Statistics Layered will go through the assumptions and it also explain how to run the analysis in SPSS. So it goes assumption by assumption. Some of them are more definition based. They aren't things you mathematically or statistically have to check. So your dependent variable needs to be a continuous measurement. That's more regarding how you're collecting the data as opposed to the data itself. So it's more in regards to, was the data collected continuous or not? Likewise with the independent variable, linearity. So I think they go overboard sometimes with assumptions. You don't necessarily have to check all of these, but I do think normality is important, homoscedasticity is important, absence of multicollinearity is also important. But the best thing to do is to check with your committee. They probably have a preference for what assumptions to check. Okay, I'll put this link in the chat box just in case. And if we have any questions, you can type those into the chat box as well. Okay, we have a question from Daphne. Can you put your citations in the chat box? Yes, I can. We're going to send everyone a copy of this as well. But here is the Tabachnik and Fidel reference. Let me put the reference in there. That's just the citation. Here's the reference that is in the chat box. I think there were any others. There may have been. I think that was the only one. For the VIF part being below 10, I do have a reference for that as well. That's from Stevens. There we go. That's in the chat box as well. Do we have any questions, any specific questions about assumption checking? And if you have any questions about the services, you can give us a call here at 727-442-4290, or you can email us and just let us know where you are in the process and if you need any assistance. Any questions? Just checking to see what's on the horizon for webinars. We do about, I would say, 6 to 8 of these a month. Okay, so it looks like we have one in a couple days that will be going more into the literature review. Why is theory important? And then searching tips to find references and journals. All right, well, have a great day, everyone. Thanks for joining, and come join us for future webinars. Have a great evening. Take care.